Question 116 reads, determine whether or not each of the following signals is periodic. And if the signal is periodic, we determine its fundamental period. So we start with A, and we can see that A is expressed as a function of cosine. And we can observe outrightly that the coefficient of t is our omega. We can call that one omega 1. And we also say that the period t naught is always given by 2 pi. This is a formula that we should all remember. T naught is always given by 2 pi over omega naught. Since our omega naught is 1, therefore we can get that our period is 2 pi, and hence our function is periodic and it has a period of 2 pi. And jumping to part B, or rather, am I finished? Yeah, of course, part B, I think I never read this one. Part B. So part B reads that our function is sine 2 over pi, sine 2 over 3 pi, a function of t. And therefore, you can observe that our omega naught is equals to 2 pi over 3. And since we know this formula, 2 pi over omega naught will always give us a period. Therefore, we obtain that our period is 3. And therefore, we can say that our function is periodic with a period of 3. So part C reads x of t is equals to a function of cosine and sine. And therefore, we can say this, can refer this one as x1 of t, and this one as x2 of t. And the angular frequency of x1 is pi over 3, and the angular frequency of the x2 of t is pi over 4. And therefore, we can obtain the period for each by saying 2 pi over omega 1 gives us 2 pi over pi times 3, you get a 6. And the period for the second signal x2 of t is 8. Therefore, we can see that there is this requirement for a function that has two functions of time. We normally say that the period of the first function must always, the ratio of the first function to the second function must always give you a rational number. And therefore, we say that t1 over t2 is 6 over 8, and we can clearly see that this is a rational number. So if this is a rational number, we need it now to find the fundamental frequency. We conclude that this is that our function is periodic. And now to determine the time, you can just can bring this on this side. So we have t2 multiplied, so this cancels out, and you multiply both sides by 8. You have 8 there. So you can, of course, get a fraction divided by 2, 3 divided by 2, 4. So you have a function that looks like this one. 4t1 is equals to 3t2. And this is our fundamental period. So we take either of them. It gives us our period to be 24 seconds. So our first three functions are periodic, and each of the period is determined. So our last function d is expressed as a function of cosine and sine, and you can observe that the angular frequency of omega 1 of x1 is omega 1 and x2 is omega 2, and therefore we can clearly observe that the coefficient of t is 1, and therefore our omega 1 is equals to 1, and the coefficient of t here is root 2, and therefore our omega 2 is root 2. And therefore, to determine our period t1, we just say 2 pi over omega 1 gives us 2 pi, and the period of the period from omega 2 is simply 2 pi over omega 2 gives us 2 pi over root 2. And for periodicity, as we have said, this is the condition. And therefore, we just say T1 over T2 to give us 2 pi over 2 pi times root 2. And we see this is not a rational number. This is not rational, and therefore we observe that our function is not periodic. So I have not done the other functions E, F, G, H. We can always look at them, or up to I. You can take your own time to look at these ones.